quite a while, and this is the best way I've seen to factor trinomials. I think you can learn it in a few minutes. It's called the rectangle method. So a little background information: if you want to multiply binomials, if you want to factor trinomials, first you have to know what it means to multiply binomials. So in this example, 2x plus 3 times 3x minus 1. This is a binomial right here because it has two terms. That's all binomial means, is it has two terms. And we've got another binomial over here, and we're multiplying these together. So some of you might have learned a method called FOIL, where you multiply the first, outside, inside, and last. This rectangle method is exactly like FOIL. It's just a more visual model of FOIL. So what you do to multiply these together is you draw a rectangle and you make it 2 by 2 so that you can put the terms in here. Now, it doesn't matter which one you put on top and which one you put on the side, but so we have a rectangle, and basically the measurements of it are 2x plus 3 times 3x minus 1. And so we'll think of that minus 1 as a negative 1. If you want to change this to a plus negative, if that makes you feel better, that's fine. You don't have to do that, but that's basically what we're doing. And this is a plus 3 here. So when we multiply these binomials together, in this square here, we do 2x times 3x. That's 6x squared. When you multiply this square, 3 times 3x would be 9x. Down here, negative 1 times 2x is negative 2x. And the bottom corner here, 3 times negative 1 is negative 3. And so the answer to this multiplication is the area inside here. It's the area of the rectangle. So in this case, we have 6x squared, and then these two corners, 9x and negative 2x, are like terms, and they can add together. So that's 7x. And then there's this minus 3 or plus negative 3. So when we multiply two binomials together, usually what it gives us is a trinomial, 6x squared plus 7x minus 3. If we would substitute any number in for x into this original expression, you'd get the same answer as in this expression. These are equivalent, just in different forms. Some things to notice about this: when we multiplied the first two together, that went into this corner right here. When we multiplied the last ones, the 3 times negative 1, that goes down there. We got to note that and observe that. This middle term, the 7x, comes from the sum of these two. So the sum of these two corners makes the middle term. And one more thing to notice, so we can understand the next step, is that the cross products in this rectangle are equal. And so if we look at that, you multiply these two together, negative 2x times 9x makes negative 18x squared. And if you multiply these two corners together, it will also make negative 18x squared. That's an observation. That's a fact that we're going to use when we factor trinomials. Okay, so that's multiplying binomials. The first thing to learn here is just how to multiply binomials like that and practice a few of those. And now we'll get on to factoring. So what factoring means is basically reversing the process that we just did. So we're going to take this trinomial and we're going to make it, and we're going to rewrite it as two binomials multiplied together. And so using what we learned in the last example, what we're going to do is we're going to take this trinomial and we're going to draw a 2 by 2 grid. But now, instead of starting out with the outsides of it, we're going to start with the insides. So we did observe in the last example that the first term is going to go in this corner. So 3x squared goes in this corner. We know that the last term is going to go down in this corner. That's a 2. And we know that these two corners, so that was our last, these two corners have to have a sum that adds up to 5x. And what we learned about the cross products is that those will also be equal. So we know these two corners will also multiply to make the same cross product as this. So the product of them will be 6x squared. So now all you got to do is think about what multiplies to make 6 and adds up to 5. So starting with a pretty easy example here, what multiplies to make 6 and adds up to 5, that'd be 3 and 2. So we can use 3x and 2x as our corners here, as these two corners, and it doesn't matter which one you put in what corner. You're going to end up with the correct answer either way. So we'll just put the 3x in this corner, we'll put the 2x in this corner. Okay, now we're almost done factoring this. What we need to do now is recreate the outside of the box. So what you want to do is just look down this row right here at the 3x and the 3x squared and the 3x, and think about what's the greatest common factor of those. So they both have a 3x in common. So that goes there. And once you have that there, the rest of the outside of the box is just going to be basically predetermined here, because this is 3x, then 3x times what makes 3x squared? Well, then that has to be an x. And 3x times whatever's up here has to make 3x. So that means this has to be a 1, a positive 1. And then x, right, this x here times this corner has to make 2x. So that means this has to be a positive 2. So the factored form actually comes out on the outside of this rectangle. The factored form of this is 3x plus 2 times x plus 1. That's it. That's the whole process. And that works with any type of trinomial as long as it's factorable. I'm going to do a few more examples, show you a few more examples if you want to take a look. We'll check it out here. Let's try another one. 2x squared minus 13x plus 15. So we know that we're going to draw a 2 by 2 grid. We know that the first term is going to go in this corner, so that's 2x squared. We know that the last term is going to go down in the bottom right corner, that's 15. We know that these two corners, the two that are left, have to add up or have a sum. We'll use sum. They have to have a sum that makes this middle term, the negative 13x. And they also have to have a product. When we multiply them together, they need to make the same cross product as this. So 2x squared times 15 is 30x squared. So now we just need to think here. What multiplies to make 30 and adds up to negative 13? So you can go through your numbers that multiply to make 30. 5 and 6, 3 and 10, 15 and 2. We need to make them add up to negative 13. So I think we're going to need to use a negative and a negative so that they multiply to make a positive and add up to negative. So we're going to use negative and negative. It's going to have to be negative 3 and negative 10. Those are the magic numbers here, negative 3x and negative 10x. Those will add up to negative 13x, and they'll multiply to make 30x squared. You can put those in either corner, doesn't matter, negative 3x, negative 10x, and we're almost done here. We look down this first row. It actually doesn't matter where you start looking, but I always have kids look down this first row. So 2x squared minus 3x, they have just x in common. That means this has to be a 2x because 2x times x makes 2x squared. That means this has to be a negative 3 because negative 3 times x makes negative 3x. And then 2x times what makes negative 10x? That means this has to be a negative 5. And if you check that bottom corner, even negative 5 times negative 3 makes positive 15. So there we have it. The answer, the factored form of this, comes out on the outside of the rectangle, 2x minus 3 times x minus 5. We went from a trinomial and we rewrote it as a product of binomials here. So that we just factored that, and that's it for that one. Let's try one more, a little bit more challenging one so you can take a look. 6x squared minus 15x minus 21. Oops, we'll go back to that. One thing that we should always look for is if these all three have a common factor. When you start to do some of these more advanced ones, you should take that out right away. So all three of these terms are divisible by 3. So what I'm going to do is just factor a 3 out. This is like reverse of distributive property. We're going to put a 3 in the front here. Just pull it out to the front. So that's 3 times parentheses 2x squared minus 5x minus 7. And that 3, now that you have that out there, that just stays out in the front. There's nothing really more that you have to do with that. Just keep it on your answer when you answer this question. So now we need to focus in on this trinomial right here, 2x squared minus 5x minus 7. And we're going to factor that using the rectangle method. So we'll draw a rectangle. I'll make a little nicer one here. We draw a rectangle. Make it 2 by 2. Take the first term and put it in the upper left corner. Take the last term and put it in the bottom right corner. The other two corners have to have a sum that equals the middle term, negative 5x. And they have to have a product of That's equal to this cross product, 2x squared times -7, -14x squared. Now you just do some thinking. What multiplies? Think about things that multiply to make -14, and they have to add up to 5. So you can kind of list some things in your head. 14 times 1, I don't think we're going to be able to make that add up to -5. 2 times 7 is another way to make 14. I think we can make that work as long as we're going to need to make one of them negative and one of them positive. We're going to need to use -7x and +2x as our corners of the box. That does what we need it to. That has a sum of -5x and a product of -14x squared. So we go ahead and put those in. Again, doesn't matter. We'll just put -7x in this corner. We'll put 2x in this corner. Look down this row. These have x in common. That means this has to be 2x. That means this has to be a -7 or plus -7, however you want to do it. It's the same thing. And since we have 2x here, 2x times what makes 2x? That means this has to be a 1. So the factored form of this part is out here. Don't forget about the 3 that we pulled out right away. That still needs to be part of your answer here. 3 times parentheses x plus 1 times parentheses 2x minus 7. And that is done. That's it. It works with all different types of trinomials. You get some big fancy ones with multiple variables in them where you have an x squared, y squared, or something like that in there. Still follow the same process. It should work for anything that's factorable. And if it's not factorable, then you'll learn about the quadratic formula or completing the square. All right, thanks for watching.